Hello and welcome to another video on Joe's Physics Corner. Today we're gonna be continuing on from the previous video. So if you want to check out that video, you can. It'll be here. Okay, so this is the next part of question 3 of the 2015 PUPC. So it's part B. And firstly, I'm just gonna read the question. It says if we just want to ensure that the ball goes over the wall without any concern about where it lands, find x, which I've set here as k because x is because I'm gonna in the next part I'm gonna set this in the Cartesian plane, so x is gonna cause confusion. So I'm just representing this x here as k. And yeah, the question wants me to find k, v, and theta over here such that the energy used is minimized. Okay, the first step here is the same as what we did in part A. We have to represent this in the Cartesian plane and consider the trajectory of the mass over here as a parabola, as it would, without air resistance. And so let's just draw the box or the wall here, which has a width of L and a height of 2L. And the midpoint here, the distance from the mass here and the midpoint here we said is k, although the question initially said x is going to cause confusion as the directions here and y, x and y. And so yeah, we're defining the displacement, the horizontal displacement from here to here as k. We're saying that initial velocity is v, which is not going to be of any use for now. I'm just going to draw the trajectory that the mass would take. Like that. It's quite ugly, but you get the point. And we know that the angle here is theta, and so the gradient would be tangent theta. And that would be useful when we differentiate the function and get the gradient in terms of L and G and K. But so how do we derive that form? Well, we know that because the length here is k, we know that the first x-intercept would be at the origin, and the second x-intercept would be at 2k times 0, because the length here is k, and we know that the distance traveled from here to here, and this distance traveled like from the start point to the vertex, and from the vertex to the end point would be same. And so the coordinate here would be 2k times 0. And we also know because the length here is L and the height here is 2L, we know the coordinate of this point, which is k minus L over 2, because the entire width is L, and we're just getting the halved value of L. We're subtracting from this point over here, and so it's k minus L over 2 times comma 2L. That's going to be the coordinate of this point. And so we have a simple parabola with the equation y equals a, which is the coefficient of x squared, which we don't know yet, times x, because the first x-intercept would be at x equals 0, and the second x-intercept, x minus 2k, x-intercept 2k, so x minus 2k, because we have our x-intercept here. And yeah, from that we could get what a is by plugging in these values into y and x. So we get 2L, which is our y value here, equals a times k minus L over 2 times minus k minus L over 2, because k minus L over 2 minus 2k is minus k minus L over 2. This would be a form a plus b, a minus b, which can be expanded easily. But before we do that, we're just gonna get the minus out of here to make it simpler. So we get minus a times k minus L over 2 times k plus L over 2 would be 2L over here. And just expanding that, for now we get k squared minus L squared over 4 equals 2L. And because we don't like leaving the expressions as a fraction, we're just gonna multiply 4 onto both sides and get minus a times 4k squared minus L squared is equal to 8L. And now simply we can get A as minus 8L over the minus into this expression over here. So we're going to change the sequence of the subtraction and get L squared minus 4K squared. That's going to be our value for A, which is the coefficient of x squared in the parabola over here. And what use have we got by knowing this? Well, we said that the gradient at x equals 0 is tangent theta. And we could get the gradient of any function or any equation by differentiating and substituting the x value of that point. So we had our y value over here. So we have y, when we just expand that, we get ax squared minus 2ak. We're just going to leave our value for a as this for now, because you see that y prime is equal to 2ax minus 0. 2ax, oh, there's the x here, so minus 2ak. And because we're getting the gradient at x equals 0, y prime at x equals 0 would be just equal to minus 2ak, because x is gone by multiplying by 0. And so that would be equal to, we know a as the expression over here, so we get minus 2k times a, and so minus 16lk over L squared minus 4k squared. And we said that would be equal to tangent of theta. To make this simpler, we're just gonna get the minus on both sides and get tangent theta is equal to 16lk over 4k squared minus L squared. And yeah, that's how we get the tangent value, but still we have k, which is our variable, not our constant. And so that is not quite the answer yet, but we're just gonna, so yeah, the purpose of drawing this parabola was deriving this equation, this expression of theta. And so yeah, we're just gonna leave our theta value like that and move on to the second part. So it's just gonna erase this part, because this is what's important. This is why we drew all this. Okay, now moving on to the second part. At the part before, we analyzed the features at this point, and so doing SUVAT at this point once more would not give any useful expression, because we used it before. And so now we're going to use this part over here. Let's just write SUVAT for now, and the xy substituent values, and let's analyze what the values for this part. What would be our displacement in the x direction at this part? Well, we know that it's going to be k, because the length here is k. That's simple. Sx equals k, and sy we don't know, because as I drew here, the length from here to the ground is not 2l, it's 2l plus this small value which we don't know. And so I'm just going to leave it blank. And what would be our initial velocity in the x direction? Well, that we could use trigonometry and say that it's v cosine theta, because it's the adjacent side. We get v cosine theta, and subsequently we get this as v sine theta. And for the final velocity, we know that this would remain constant. However, the vertical velocity here, the final velocity here, would be 0, because it's at maximum height, where the effect of gravity minus g, acceleration, has caused it to become 0 at this moment. And we said before that because there is no force acting on the system on the x direction, this is going to be 0. And we have this system over here, and so all we have to know is t. Now the trick here is knowing that t for both sides is going to be same. And we could get t here in terms of k and v and theta, and then get the same here, and then substitute it into the SUVAT equation to get s. But that's quite tiring. That is unnecessary, because this I have a simpler way to get the expression for k, which is as follows. So we know from the SUVAT equation, Sx equals uxt plus 1/2 axt squared. We know that this should be the case. And because ax here is 0, we could eliminate this part and get t is equal to sx over ux, which is equal to k over ux we said is v cosine of theta. So the first expression for time we get is k over v cosine theta. But that's not the only time value we could get. There is a different way of getting the value for t, which is using the y expressions over here. So we have u as v sine theta, v final velocity is 0, and acceleration as minus g. We're going to use v equals u plus at. Simple. We get by reordering this equation, we get t is equal to v minus u over a, which the y is here. And so we get vy, which is 0, minus v sine theta, so 0 minus v sine theta over ay, which is minus g. And so we get v sine theta over g. And that we said that is time. And we said the time should be same for this here and this here. Time is same. So we have this equation over here that we derived in terms of y. And now everything is simple. I'm just going to move on to this part. So we can do cross multiplication and get v squared sine theta cosine theta is equal to kg. And now the trick here, well, before we do that, we're just going to rearrange this like that. Now the trick here is that when we look at the question, the question says we have to minimize the value for 1/2 mv squared, which is the input energy, the kinetic energy we apply to this system. And yeah, it says we have to minimize 1/2 mv squared. And we know that 1/2 m is a constant, so this basically means we have to minimize v squared. Minimizing v squared is our ultimate task. And we have an expression for v squared as like that, as here, kg over sine theta cosine theta. And what could we do with this? Well, in order to minimize this value, so decreasing this value, it would mean that we have to increase the denominator, because when we increase the denominator, we decrease the result. As like 1 over 3 is bigger than 5 over 1. It's by increasing the denominator, we decrease the result. And so we have to maximize the value on the denominator, which is sine theta cosine theta. So how do we do that? Well, we graph sine theta and cosine theta and figure out what its maximum value would be. And how do we draw that? Well, we know from the double angle formula, the sine 2 theta equals to sine theta cosine theta, that sine theta cosine theta would be equal to sine of 2 theta over 2. And so if we graph this equation over here, which is basically the same as graphing this, we get something like, well, it's going to follow the same format, but we know that the period, the value here, which is originally 2 pi, we know that that's going to be pi because we have to input pi to get 2 pi. And so it's going to be 0 here, pi over 2 here. And because it's over 2, its maximum and minimum will no longer be 1 and minus 1, but 1/2 and minus 1/2. And we know that the value for theta here, when it's the maximum, is pi over 4. And this same shape will repeat on and on. So we could say that the maximum value of sine theta cosine theta cannot exceed 1/2. So the maximum value is 1/2. And that's basically it. We figured out what the maximum value for sine theta cosine theta is, which is 1/2. And we also know that the value for theta would be pi over 4. So that's our first part. That's our first part of the question done. We now know that theta is equal to pi over 4. Okay, so now we're left with k and v, and by by knowing that this is equal to 1/2, we could say that, let's get that over here, we get v squared is equal to kg over 1/2, so it's equal to 2 kg, and so v squared would be equal to the square root of 2 kg. But still we're not satisfied because there is k in our equation, and we can't let that happen. But what we can see here is that we know the value for theta. And when you see here, the equation we derived before with the parabola, we see that when we input theta into this equation, it should be the same. Because the problem we had before was having two variables, but now, because we could say that as a constant of that, we could express that with theta equals pi over 4, we could get 16lk over 4k squared minus l squared would be equal to tangent of pi over 4, which is tangent of 45, which is 1. And so, by doing cross multiplication, we get 4k squared minus l squared is equal to 16lk. And so, 4k squared minus 16lk minus l squared equals 0. So that's an equation with only one variable because l is a constant given by the question. And so I'm just going to erase some parts I don't need. So this part I won't need. This part, all of this I won't need. Okay, so we're pretty much done. So we're just going to solve this quadratic. So we get assign b prime as minus 8l. So applying the quadratic, the even quadratic formula, we get k is equal to a at the denominator and minus b prime, which is 8l, plus minus square root of 64l squared minus ac. So wait, minus l squared 64 minus l minus 4l. So that's going to be plus 4l squared because it's a minus and a minus. And so we get 8l plus minus square root of 68l squared over 4. We could put the l out and maybe get the 2 out, 39. No, and so we get 8l plus minus square root of 68l over 4, and that's going to be our value for k, which is part of the question. And so that part's done. We now know k, and by inputting that in v equals square root of 2 kg, we get v equals, by doing that, we get v equals square root of 2 times that expression over here, so 2g times that, and so that times 2g, we get 2g, so we get 2 over 8lg plus minus square root of 68lg over 2, because we got 2 like that and then erase the 2 here. So that's my final answer. We get v as square root of 8lg plus minus, wait, is this? That's gonna be bigger. So square root of 68 is bigger than 8, and so doing that would give us a negative value. But g is a negative value. No, g is a positive value. So we're gonna have to do plus. Minus won't work. So that's my final value for v. That's my final value for k, which is v, as the question wants us to find in the original question. And that's my value for theta. And so that's the answer. Theta equals 45, k equals 8l plus square root of 68l over 4, and v equals square root of 8lg plus square root of 68lg divided by 2. That's the answer. And yeah, see you in the next video.